Hi everyone, this is more like a book review more than a lecture because I think I'm one of the more junior developers here, both in terms of JS and in terms of working in this company. So one thing that I learned is over the past year is I actually don't know JS. I kind of know, but not really. So sometimes we see all these things, like there's a lot of memes about JS, everybody says JS sucks because of all these kind of things. Truth is, yes, it kind of sucks, but maybe we can use that suckage to make our lives a bit better also. So this presentation is more is based 90%, I guess 100% on this book, but I don't cover everything. There's a lot of other intricacies that they go through. So I will cover some of the examples that come out from this book. So this is actually a series of books by Getify, and you can just get it on his GitHub page. And this is the fourth book, I think, in the series. So it mostly doesn't really explain like the JS specifications like you would expect, because if your book just explains the specification, then just read the specifications. But how it helps you understand the specs by explaining how the engine interprets JS code. Mainly covers ES5, but there is ES6 examples sometimes, and it assumes no programming background. So if your girlfriends or what want to learn JS, you can start from the first book, right? And then yeah. So most people would say that JS has no types, but that's actually just a oversimplification, because there is actually kind of types that is programmed into JS, right? So we have null, undefined, boolean, number, string, object, and symbol from ES6. So with this kind of types, we kind of expect all this output, right? So true, yeah, everything's correct, very nice and dandy. But there's kind of one type missing here, which is actually null. Null is actually an object. So this is one of the JS magic that is a bug actually that has been persisted in JS for nearly 2 decades, and it will likely will never be fixed, even though it's a bug, because too much existing web content depends on this. So this is just one thing that you have to know.
This is a feature.
Yeah, it's a feature. Right, so this is the recommended way to check specifically for null, because null is the only primitive value that is both falsy and returns the object. So in the specifications, functions are actually callable objects. It's not a separate type by itself. And one good use of function is that as an object is that they can have properties, like for example, the length is the parameters. Interestingly, arrays are displayed as object and not some special types. So let's go into array. So most of you who have done JavaScript for quite a while might know already that arrays are just containers for variables, right? It doesn't matter what you put in, it doesn't matter if it's all different types. So you can expect, like with all objects, arrays are not that much different. You can add values like a key value pair, so like the foo bar, you can add it to an array, still works. But very funny is that the engine will create a sparse array if you skip natural numbers. So here, like you skip the 1, but the thing is the length is still 3. But just like a normal JSON object, you can still access it with a square bracket or dot notation. Right, so it both works. And printing the array looks like some kind of weird array or object hybrid thing. But if the key is a natural number, even if you put it in a string, it gets coerced into a number. So you actually do get up to 13 or at least 14 length. So when working with sparse arrays, there are some differences in how you define them. Having it to be empty versus initialized with undefined, you actually act quite differently depending on what you do. So this is, yeah, just when you print it out, it's different. And you can actually really see the difference when you start using like something like map. So a bit of a sidetrack. One thing to note when working with arrays is that a reference in JS points at a shared value. So if you have 10 different references, there are always distinct references to a single shared value. None of them are references or pointers to each other. So when you pass in argument x here, right, and then you push, you get 1, 2, 3, 4, and when you reassign it, it's not the same object anymore. It's a new reference. So in order to change to 4, 5, 6, 7, you can't create a new array, but you have to modify the original 1, 2, 3, 4 such that you get 4, 5, 6, 7 in this case. So you can't just assign a new array. So let's move on to string. So what about strings? We like to think of strings as an array of characters, right? It kind of acts like we expect it to be, right? Both the same. Now once you try to print it out, you find that there's some different behavior. So JavaScript strings are immutable, or arrays are quite mutable. So over here we have So over here we actually change the middle one to the caps, but only the array changes, whereas the string doesn't. So none of the string methods that author its contents can modify in place, but it creates and returns new strings. Many of the methods that change array of contents actually modify in place. So moving on to numbers. Numbers are surprisingly weird. Most of it is due to floating point representation, right? So it's this very famous case. But what if you want to compare floating point numbers like this? So this is how you would try to compare the numbers. You can't really get equality, but it's close enough. And then we have special values. So funny thing is that not a number is a number. Right, and this is actually part of the specification. It's a special value that will make any equivalence check to false. So that's why you get this. And I think part of our code actually had a case like this, right? That's why you don't compare to not a number directly. So how do we check for not a number? We use the provided isNaN. But that gives another problem, right? Because isNaN takes it like way too literally. So if the thing is a string, isNaN will be true. So luckily for ES6, the isNaN function is provided in the number object. So once you use a number isNaN, then you get something more expected. But if there's a polyfill, you can also do this, right? But this is not really a very interesting way to polyfill. This is so boring. So this is actually a more interesting way. Because not a number is the only value in the whole language where this is true, where isNaN will never equal to isNaN. So yeah, just a very interesting way to do the exact same thing. So another special number we have is infinity. Also due to specification, division by 0 is well defined. So if an operation like addition results in a value that's too big to represent, the round to nearest specifies what the result should be. So the max value over here, like the 2 to the power of 969 is closer to the max value than to infinity, so it rounds down. Whereas 2 to the power of 970 is closer to infinity, so it rounds up in that sense. So yeah, and infinity divided by infinity, infinity divided by infinity is just not a number. And then so the opposite of what you would expect infinity to be is 0. Most consoles get this correct. So 0 divided by -3, get a -0. The specs seem to really want to lie to us. Right, so when we convert it to string, right, -0 is printed to a normal 0, where you would expect it to still maintain the -0. But you convert the -0 from a string, it actually works, you still get the -0. So it's one-way conversion. Now, apart from mathematical philosophy, there's a reason why we want to know whether it's a positive or -0. Like, for example, a vector that's decelerating or something. Then when it hits 0, you want to know which direction it came from. So that's probably why we want to have it. So we need to be a bit more creative to get things right, when we want to compare, when we want to find out whether it's something is negative 0 or not. So here we use the negative infinity to actually check the negative 0 value. Because negative infinity is reliable, and negative 0 is not really reliable. And another special value is undefined. So I think we have talked this in our chat before. One thing is you can actually assign a value to undefined itself. So even in strict mode, you can still assign undefined within a functional scope. So what to do when some guy decides to put undefined to a variable as a variable? So we can actually use void 0. I think some of us are using it right now. We can use void anything and it will still work, but void 0 is more common due to convention taken over from C. And then next we have fake natives. It's kind of natives, but it's actually just functions that are built into JavaScript. So these are the natives that we have. And expectedly, using the object wrapper, we will get it as an object, right? But there is a class property. It's not an old type of class, but more of the classification of what type of object it is. And using the object wrapper directly can cause some problems. For example, objects are truthy, so you need to actually extract the value out first before you use it. Alternatively, there are also other ways to implicitly unbox the values, like so. So, yeah. It may not be obvious, but JavaScript coercions always result in one of the scalar primitives. So values like string, number, boolean, there is no coercion that results in a complex value like object or function. So next we go to, of course, the best part of JavaScript, which is coercion. So the most obvious way is to explicitly typecast variables, right? You just use string, you just use numbers. But there are other ways too, right? Like the plus unary. Yeah, so B is supposed to be a string, right? So we use the plus unary and we convert it into a number over here. And then you can, of course, do string C here. So you can just typecast by using the plus. But be careful of using the plus unary, you can make like some confusing code here. So try not to use it, but know that it exists. And the most commonly used reason to have the unary is to quickly create a timestamp without the use of date.now. So you can actually just plus new date and then you just get a timestamp. So maybe instead of using a weird thing like unary, we can just number or pass in, right? As long as you know how they work, right? If you pass in a string of 100, it works as planned. But pass in only takes in a string, so it implicitly coerces a string to true. Well, for 100 px, so yeah.
What? Because it's passing, right? They try to pass.
Yeah, as much as it can.
Yeah.
Makes sense.
Yeah, so if you think about how it works, it kind of makes sense. Because this one becomes the word true, the string true. So this one becomes 100 px. So how pass in works for this is it takes values until it hits something that it cannot pass and then converts that into the number. Whereas for number, it works the different way, right? It just tries to get a number out. It just tries to coerce it into a number. So number will coerce values to number, nothing else. That's why the 100px fails. So we can analyze what's doing here. So you expect passing in some infinity value, right? So this one will become infinity or something, right? And then you should be getting infinity in base 19, but instead you get 18. So now we know that pass in expects a string, so there's some implicit coercion happening here. So what we are getting is actually just the value 1, because it stops when it hits the slash sign. And then yeah, so if you look at the base
Because I infinity string
Yeah.
as a string.
Oh, sorry. Yeah. So it gets infinity. So it starts with I and then there's an n. Then you get 18. Yeah. So that's how you get 18 for your. Yeah. But there are some. What if you have some value that you want to pair with like descriptive properties, right? In this case, you can take the advantage of the fact that pass in it coerces a string. So you can set the toString value to give you the number that you want to have. So as useful as implicit coercion is, you know that implicit coercion is also a major headache of JS. Like we have Zhong Liang like to say implicit coercion is the evil of all bad code or something like that. It was one of our codes for a while. So over here, when you add two arrays together, it actually casts into a string, right? And then if you C plus code, of course it will become a string also. But then if you use the minus, you can actually turn the string into a number. So that's useful, I guess.
Useful for reading book.
I mean, it's nice to know. Sometimes you might see some other people's code like this, and then you understand why. Right? In this case,
It becomes a string and then it
it just in this case it just becomes number. It coerces into numbers. Yeah.
Is it subtract a number inside or the?
It just coerces into number.
Try to use
Type 4, right?
No, I mean try to use the.
So we like to use the or and and. We like to use the operators a lot, and we would think that it might coerce to Boolean, but actually it's not really Boolean, right? Because it will return the string values. It doesn't really coerce it to a Boolean. So it is I put here roughly equivalent because it's actually the outcome is the same, but there's a nuance difference. So in this case, in this longer form, there is if A is a more complex expression, like for example one that might have side effects, like calling a function or something, the A expression will be evaluated twice, right? But if you just do this form, the A expression is only evaluated once.
So just get the value of the first one.
And yeah, so another thing we have to take to note is also when you do the OR, right? This is a FOSSI value, so you actually still go to the default. So you can't really just use you actually need to not pass in anything rather than to pass in an empty string. Right. So there are also ways to implicitly unbox values like so. What was this about? Have I talked about this already?
Yeah.
So okay, so we are down to the last topic. Thank God. So one of the most interesting things that we can actually do is a bitwise operation. So there's this tilde, right, which is it actually does a bitwise NOT, in case you didn't know. So tilde x is roughly the same as negative x plus 1. So why is this useful, right? It's actually not very useful when you first look at it. But it's nice to know that bitwise NOT of -1 is 0. So you can actually handle the special value of -1 for failure more elegantly than just equals equals equals. I mean, more elegantly is actually subjective. Yeah, it depends on who decides what. Yeah. So now that we actually know, we actually kind of have an idea of how it works, right? This kind of thing shouldn't face us. Can kind of understand, right? Coerce to, based on the specification, I think this is coerced to a number. This one is coerced to a 0. Then this one is coerced to an empty string. So that's why That's why they are not the same. And then we have something like this. So we talk about the string concatenation, right? Right, so 2 plus 2 minus 2 is 2. Very good. 2 plus 2 minus 2 is so here there's no coercion, and then here there is a coercion back into both of them being numbers. So this is the last page. I still don't really understand how it works, but this is everything. So that's all.
Number 2.